Okay, Edx M3 June 2010 question 3 on elastic potential energy and work done. Here's the question, so pause the video and have a look. Okay, let's carry on. On the next page I've drawn a diagram and also pasted in the question. We have to find the value of lambda, the modulus of elasticity, and we're told various information, the coefficient of friction, we're told sine theta, so we also know cos theta. I've worked those out already here. It goes 0.7 meters up the plane before coming to rest again. So I've worked out the height risen because I'm going to need that for gravitational potential energy. Let's work out the extensions at the start and the finish. X1, the extension is 0.6, and X2, be careful here because it's not unstretched at the end, in fact it's compressed. It's compressed to distance 0.1. Now the fact that it's a compression doesn't matter here because we're going to be concerned with the elastic potential energy. So the elastic potential energy expression, you need to recall this, lambda x squared over 2L. We're basically doing the preparatory work here, and we'll put it all together on the next page. We'll also need the friction. Friction will be mu r, because it's moving up the plane, and it'll be 0.15, because mu is 0.15, I think. Just check that again, 0.15 times 0.5 g cos theta, from resolving perpendicular to the plane the usual way. Okay, on the next page then we can put the energy equation together. So we're going to, and then I'll put these terms in. So we're going to say that elastic potential energy initially goes to elastic potential energy at the end plus mgh, the increase in gravitational potential energy, plus the work done against friction, which will be friction times 0.7. Okay, so putting all those terms in, we're trying to find lambda, remember. Lambda times 0.6 squared over 2 times 0.9 equals lambda times 0.1 squared over 2 times 0.9 again, plus 0.5 g times 21 over 50, plus mu r times 0.7, so 0.15 times 0.5 g cos theta is 4/5, all of that times 0.7. Right, those are the terms. When we collect up the values of lambda, the expression is lambda, we get 0.1944 lambda equals, and calculating the other terms, it comes to 2.4696. 4696, giving lambda equals 12.70 to two decimal places. And that's it. That's the answer to the question. As far as marks are concerned for this question then, we've got, I can put them all on this page, I think, just change it to red here. Let's see. There's a total of 9 marks. Yeah. There's an M1, A1 for resolving and getting the mg cos theta term here, and an M1A1 for the lambda x squared over 2L, getting those two terms right. Oh, an M1A1 for the energy equation, that gives us that gives us 6 marks. Where's the other 3 then? Oh, putting the actual values in and getting the correct values of the initial and final extensions, that must be just about it. That's 8, and of course an accuracy mark for the final answer. Okay. Right, thank you for listening. I hope that was useful. I'll leave you with some information about the Further Maths support program.